I will keep it to 10 minutes. So I think that was actually the perfect introduction. Thank you. That was you've made many of the points that I was going to make, but in a kind of ecosystem way, which is really useful actually. And that's going to help me to go a little bit faster. So firstly, I will talk about some of these challenges of achieving zero emission roads and some of the comparison between using batteries or fuel cells to do that. A little bit about the company, and then a bit about fuel cell system development and where we're going in the future. So I think as we were just talking about, actually, that generally the global focus has been on battery electric vehicles as the prime way to move away from using carbon fuels on the roads. I mean, this is critical. I think in the table we saw earlier on, in India, it's the second biggest producer of CO2, plus obviously all the other emissions, NOx, etc., and particulates that we need to get rid of. So battery electric vehicles are being, they're accelerating the use of those cars. I drive one myself, so I see the practicality of that today. But they do have a lot of issues, and some of those we've talked about, but others I want to briefly mention. So one of the biggest things is the supply chain. So for the batteries we're using today in cars, they're almost exclusively lithium-ion based batteries, and the materials for those, lithium and cobalt, etc., they're tending to come from parts of the world that we don't have control over, and therefore there's concerns about that. Do we become reliant on raw materials that we can't control? And that's the same for Europe, it's the same for India, it's the same for most countries in the world that don't have, big sources of lithium or cobalt or other materials. The sustainability issue is something that's becoming more and more understood as well, that whilst there is work being done to improve the reuse and recycling of batteries, there aren't really any economic solutions. So I mean by that, at the end of the battery life, however long you've used it for, you have to pay to have it recycled. And even then, the amounts of material you can reuse are relatively limited. If you were going to move every vehicle on the road to electrical power, then that is a massive increase in the amount of electricity used. And again, that was talked about today in terms of terawatt hours of electricity you'd need to do that. And also the peak demands become very difficult to manage, because typically people all want to charge their vehicles at the same time during the night. And again, if you're using a lot of solar, you've got your energy during the day. So again, you've got a problem how you align the supply and demand. Infrastructure, I think that's just been perfectly illustrated, the difference in the infrastructure requirements and the challenges for battery electric vehicles. The range is also restricted. The batteries are very expensive, and there's an almost linear relationship between the weight and the volume and the cost of the batteries as there is to the range, whereas with fuel cells, you just need to put bigger tanks in to get more range. Costs, we know the batteries have, the cost of batteries has come down considerably over the last 5-10 years, but that does mean that there's probably less opportunity for cost reduction from where we are today. And as I mentioned before, this peak versus demand issue, it's very challenging to manage that when you've got everything running on battery electric vehicles. So fuel cells. So we see fuel cells having the ability to overcome not all of these issues, but quite a few of them. So, for example, for fuel cells, there's really one ingredient that needs to be sourced, which is the platinum, currently used mostly in exhaust catalysts and highly recyclable. So, I'm not saying it's not a challenge, but it's less of a challenge in terms of the supply of the materials, and most of those are steel, aluminium, plastics, etc. Those materials can be more generally available. Much more sustainable. Fuel cells are 95% recyclable, and they actually have a positive economic value. So somebody will pay you for your fuel cell at the end of life. They'll take it away. They'll either make it back into new materials for fuel cells, or they'll pay you for the other materials. So this makes the end of life question much less difficult to answer. From the power point of view, again, this potential for using off-peak electricity or potentially turning off wind and solar when the grid doesn't need it, and using that to turn that into hydrogen, and then the ability to use it as transportation gives it a completely different perspective from using electricity only. again, hydrogen refueling stations, they're expensive, but they are the one-to-many rather than the, you know, so that again gives you that advantage, and I'll illustrate that a bit better in a minute. Again, benefit of the range is clear as well. So fuel cells are expensive today. There's no way to get around that. I'm not going to pretend to you that the technology is low cost, but if you look at the opportunities for cost reduction, they are also massive. So, and a lot of it is volume driven. So it's this, we had the discussion before about the chicken and the eggs. I say the ability is there to make cheap hydrogen, and actually if you can provide enough of that available hydrogen at a low enough price, the cost to run the vehicles will encourage the use of fuel cells, and more volume will really bring that cost down as well. And the other advantage I haven't really talked about here is the ability to really to localize as well. We could come and build fuel cells in India as well as anywhere else in the world, and a lot of the supply chain could easily be able to support that. So I won't dwell on this too much, but I think there's a couple of important things here. The total cost of ownership is very dependent on the cost of the hydrogen as well. So yes, there's the capex cost of buying the fuel cell initially. That's something that's being worked on, and as I said, with volume, that cost has a huge reduction potential. And the other advantage, as you can see quite graphically illustrated there, I rather like this, it's just showing you just how many hydrogen fuel cell cars could be refueled in the same time as it takes to refuel, recharge a battery electric car. So that's the pitch. But it's just very briefly, as a fuel cell manufacturer, we've been doing this for 23 years. We've built up over 1,000 patents. We employ 250 people around the world, and we work across a lot of industries. So we're here really talking about automotive, but we are in drones, we're in forklifts, we're in backup power systems, and we're also working on flight as well. So all of this is PEM-based fuel cells, so which is really the only fuel cell technology that really works in motive applications, because it works efficiently at ambient temperatures rather than having to be heated up first. So just really some information on some of the things we've been doing. So this is our one of the projects we have right now, taking on that really big challenge, the heavy-duty trucks. We're collaborating with a couple of companies in the UK and working on meeting this challenge and putting on the road a hydrogen fuel cell powered truck. And the collaboration is something that's been critical for us, and we've also been working on a project with a bus company and a Chinese car manufacturer, where we've been developing fuel cell technology to address both passenger vehicles and heavy-duty vehicles based around the same PEM-based technology. Just a very quick comparison here. We use a slightly different variant on what most people do for high power, which is liquid cooled with a glycol coolant. We actually use direct injection of water in the fuel cell. Okay. So just coming to a quick summary then, we've developed a couple of products that are now being used for our customers and development. We're working on the future. There we go, that's it.